Hey folks, I wanted to show you how to use some real world technology in order to create box plots and to learn more about how we can determine whether there's outliers in our data. Now, I would like to do this in Google Sheets, but Google Sheets does not allow you to create a box plot. In the old days, like last year and the years before, I usually ask students to get a graphing calculator, and they do produce box plots. But since I'm not making you get a graphing calculator, I'm going to show you how to use the programming language R in order to make box plots. We are going to program in R via something called Google Colab. And you know what? I'm not even going to show you how to search for it. I would like you to use the link to Google Colab with R in Canvas that I have provided you. If you go directly to Google Colab, the code that I'm showing you will not work. You need to click on the link that I provide that makes Google Colab into an R programming environment. Okay, now, sorry about that. Let's go on. I made up some data here. And let's get rid of this. And I want to show you how easily you can take this data. By the way, these are just numbers. This x is a variable, and I'm storing these numbers in the variable x. Now, I'd like to do a box plot of those values, and it turns out that R makes it rather simple, as you saw just a minute ago. I just do box plot R. So I'm going to go ahead and run that. And there is the box plot that I get. And then we're going to play around with some things. So one thing I'd like to show you is that we can make the box plot a little fancier. So for instance, we could change the color of it, because that's a little boring, just plain old gray. So I'm going to make it blue. And then the other thing we could do is make it so it's a little more narrow. And you'll see maybe there's an advantage to this, maybe there's not, but I'm going to throw it in there for now. And maybe we'll decide whether or not we're going to keep doing it. There we go. So we've got a nice reasonably drawn box plot and the color that we want. Now let's go ahead and try to do a couple of fancy things. I would like to use some calculations to try to determine what the quartiles are, even though we can see it here in the box plot. There is a function in R called 5num, and 5num lets you see the 5-number summary of a data set, like the one that is stored in X. And here's our 5-number summary. Here's the first part, second part, that's Q1 right there, that's the median, that is Q3, and finally the max. Again, 1, 2, 3, 4, 5. We are going to take that apart and just grab out the, let's do fnum equals 5num of x. Fnum is a variable, and we will take that variable apart. We will go ahead and dissect it a little bit. I'd like to get just Q1, and that is fnum 2. In other words, this is the second element of fnum, and I notice how I use square brackets, not regular parentheses. Then we're going to do Q3 equals fnum of 4, and again, that is Q3. That is the fourth number out of all these, and I use square brackets, not parentheses. And then we're going to calculate the IQR, which, do you remember how to do that? Do you remember what it is? Hopefully you do. Here we go. It is Q3 minus Q1. And so that's a pretty easy calculation. Oh, one thing I did want to check is I wanted to check and make sure that when I did this fancy stuff to get Q1 and Q3, I wanted to make sure that it actually worked. So I'm going to go ahead and print Q1 and Q3. And I'm showing you this because this is a habit that I would like you to adopt. If you regularly check parts of your code as you write them, you will find errors before they get to be too complicated. Anyways, I'm going to go ahead and hit run. And it looks like I was able to pull the Q1 correctly out of here, because it's this guy here. It looks like I pulled that out correctly, and then Q3 I pulled that out correctly. So far my code's working, so I can go ahead and get rid of these print statements. next, we're going to take the IQR and we are going to calculate the lower fence of this box plot. Now, what's a lower fence? The lower fence is an indicator in a data distribution that tells us any data points in my set that are lower than this will be considered outliers. So we're going to do Q. With the lower fence, we take Q1 and we subtract the IQR times 1.5. And for the upper fence, which tells us whether we have outliers at the top of our data set or in the highest values, Q3 plus IQR times 1.5. Okay, so then we're going to go ahead and print those guys. And this will give us a better understanding of outliers. We'll do a little bit of practice here. So I'm going to go ahead and hit run. And when I do, I now am not looking at Q1 and Q3 anymore. I'm printing out lower fence and upper fence. So the lower fence must be 4.25 and the upper fence must be 18.25. Now, I'd like to point out that there is no 18 in my data and there is no 4 in my data. And so what happens is when we go to draw the box plot, the maximum whisker only goes to the maximum in our data set, which is 15, not 18. The minimum whisker only goes down to 8 because the minimum data in our data set is 8, not 4.25. So we have an upper fence and a lower fence, but all they're telling us is that there are no outliers. And when we draw our whiskers, we do not draw the whisker to the upper fence and lower fence unless we do have outliers beyond them. And even then, even when we have outliers, we only draw the upper fence up to the maximum value inside the upper fence and down to the minimum value inside the lower fence. And when I say maximum value inside the upper fence, I mean maximum value out of all these values. So if we did have a data point that was 17 or so, 18, I'll leave. Let's do an example. Here we go. So I'm going to go ahead and let's actually see what happens if we have a situation where there's an outlier. Let's see what the differences are in drawing the the fence, the whiskers, the upper whisker and the lower whisker. So here we go. I'm going to go ahead, since it says our upper fence is 18.25, I'm going to try putting in a data point of 20 and hit run. And when I do, we can now see that I have an outlier at 20, and my upper whisker, my maximum whisker, still just goes up to 15. That's good. Things are working well. The upper fence had turned into 17.5, and so anything that is above 17.5 in this data set will be considered an outlier, and so that 20 is. The maximum value, why does the whisker not go up to 17.5? Because the upper fence is 17.5. Well, if we look at my data, I have no 17.5 in my data. And so therefore, the upper whisker will only go as far as the maximum value in the data that is below the outliers. All right. What about the lower fence? Let's play around with that. I'm going to go ahead and get rid of this outlier, and I'm going to go ahead and put in a number smaller than 5.5. Let's try maybe 4. See what happens. I'm going to hit run, and no outlier. Oh, because when I put in that 4, it changed the lower fence. It dropped the lower fence. So let me see if I can find a good outlier value. So if I go back to my original data set and I go to try to tack on an outlier that is on the lower end, I could try a number like, see it right here, it says my lower fence is 4.25. So you'd think I could throw a 4 in there. And by the way, normally we don't try to make outliers in our data. The only reason I'm doing it is so that you can see the differences in how box plots are drawn depending on whether there's outliers or not. So anyways, and where the outlier is and what the other data values are. So let's try putting, I'm going to try putting a value lower than 4, much lower. So I'll go down to 2 and we'll hit run. And it looks like that worked. I was able to make an outlier at 2. And then the minimum value, the minimum whisker is still set to 8. Let's take a look. So we've got a lower fence of 3. So if you didn't really understand these fences, you might think, oh, I'll draw the whisker down to 3. No, don't do that. There are no 3s in the data set. The lowest number in the data set is 8, other than the outlier that is 2. So what we do is we would draw the lower whisker down to 3 if there was a 3 in our data set. And then since there isn't, we draw the lower whisker down to the lowest data value that is in the data set. And then we draw any outliers after that. And in this case, there's an outlier of 2, which is definitely below the lower fence of 3. Now, if you're not following me perfectly, it's okay. I've got some exercises where you can try this yourself and get a feel for how this works. And you're going to be using Google Colab and R, and you're going to be changing these values and testing them out and seeing what happens. Let's see here. Before we go, I wanted to try another little experiment. So I was telling you that if there was a 3 in the data set, that the lower whisker would go all the way down to it. So let's go ahead and try putting a 3 in the data set. Now again, in the real world, we don't just arbitrarily add points to our data. I'm doing this so you can see what happens to the box plot. So I'm going to go ahead. Right now we've got the minimum whisker going down to 8. We've got an outlier at 2. And the lower fence that was calculated is 3. Let's see what happens here. I'm going to go ahead and hit run. The lower fence remained at 3. And so what happened is now our minimum whisker actually goes down to 3 because there is a 3 in our data set. And the outlier is still at 2 because 2 is still lower than our lower fence, which is 3. All right, that is a quick introduction to using box plots and R programming in order to better understand how we determine whether there are outliers in our data. You're going to try some exercises now, and hopefully everything will come clear to you.